Hello, everyone. I've got a good amount to get through. I submitted a 30-minute talk and they asked me to do a 45-minute talk, so I've probably got about an hour and a half's worth of content. So we'll try and get through as much as we can. My background, I'm a back-end Python developer primarily, mostly doing web apps, REST APIs, libraries, data plumbing, all the various other things that Python gets used for. My problem in the domain is all over the place. These things that are up on screen at the moment are pretty much everything that I've done just in the last few years, alongside some time in the PhD. Mine's doing some education work. Some of these things were built new, but some of those have many years of history behind them and require a bit of renovation and zhuzhing up of things along the way. So why am I talking about testing? I want tests to be stronger, less flaky, clearer, more maintainable, and simpler, clarifying intent. Fewer surprises in this code now and then, both now and further down the line, train line or otherwise. I also hopefully have some of these tests being a bit less dismay-inducing, so that we don't have maximal sadness whenever we return to testing. So I have some opinions, and it's likely that you will too. We'll try and keep it to questions, but do feel free to harangue me and suggest some other things later if you would like to. My scope is mostly unit testing. I'm not going to be a purist about what counts as a unit test and what doesn't. I want to preserve the intent of tests. I want to make things readable. I want to make things maintainable. Mainly, I want to know that if something breaks, I can see if I need to fix the code or rewrite the tests to match the new intent. So to further disappoint my title, here are some other things that I'm not covering. We're not talking about behavior-driven development. Behavior's good for that. I'm not talking about accessibility. WebAIM has some good tools for web standards and so forth. Observability and live bug reporting, you might want something like Sentry or Glitch Tip. User acceptance testing, there's only so much you really can or should automate in the code. Automation takes a lot of the heavy lifting, but please do remember to keep humans in the loop. Not really dealing with end-to-end testing because most of that is done with front-end stuff these days. Code analysis tools, PyCQA has good things for that, and MyPy. For profiling performance testing, I have used Locust in the past, but that's probably a whole different talk. I was going to suggest maybe a different conference for a security testing talk, or you could go back in time and listen to Simon's talk this morning because that covered some of those things quite well. So let's look at how to be a good code janitor. So it's easier to maintain code when you know what it does, and it's much easier to maintain a test when you know what it was intended to do. When you refactor the code, is it breaking something it shouldn't? Or does the test need to be updated? So, can I be clear about what it is that a test does? Things that I might want to look at. Aiming for readability, which helps you as much as it helps anyone else. Documenting intent. If you can't document your intent, document your despair. And leave breadcrumbs. So you don't need to explain everything that's happening every time, but you can at least show people the way so that they can follow their nose to where all the various parts of documentation that I'm sure you've written are elsewhere that will explain what it is that's going on here. And yeah, if you do have external project artifacts that you can link to, like acceptance criteria or issues or stories or whatever else, then please do that in those places so that people can find their way home. And yes, try to name tests obviously and consistently. I know this is hard, but it's a good thing to get some practice with if you can. Can I be helpful when test assertions fail? This error that we've got here, this assertion error, is it helping us to understand what's wrong? Oh no, 1 isn't 0. This isn't a great start. You won't always have time to gold plate your tests, but even a small explanation can give some hints as to what is wrong and why when someone sees a broken test. So in this case, I'm just checking the call count of a mock, which I'll talk about later, saying, this thing should have called the voucher checker, but it didn't. If you can't find a way to add a message directly to your failure, then putting something in the doc string for your test is usually a good idea, just so that people know what's going on. So one thing that happens a lot in tests is having warnings about stuff showing up when you're testing failure cases. You might also have logging showing up in the middle of your test cases, and it can be quite hard to work out what's going on through all of your log statements. So there are ways around this. We can actually check for these things using things like assert logs or assert no logs if you have a later Python. There's also assert warns, and you can do regex matching on that and other such things. There are ways of doing assert no logs in earlier versions of Python, but that's probably something that you would want to go to Stack Overflow for. So let's look at every Python programmer's favorite thing ever, mocking. Why do we want to do this? Yeah, sure, just to get my tests to pass. No, I like to think of this as border controls for your code, or interfaces between your systems and subsystems and services and so forth. Interfacing, as we learned in a talk yesterday, is something that sits between your layers and makes things more stable. And that's the same for clothing as it is for software, all going well. We also have fixtures or factories, where we can codify some assumptions that we're making about the shape of our data. And mocking is setting some expectations around something else's code. So how do I check that another piece of code will be run without calling it for real? This is where we use this unit test mock patch. This is inside a unit test case. Other frameworks have some other ways of setting these things up, but it's much the same, generally speaking. Here we have an annotation. So we've got this. Can I get a mouse cursor? Let's find out. Oh, I can't see it very well. Okay. Yeah, this bit. Mock.patch. That's there. And there we have this function path name here, which is saying the piece of code that we want to do some things with. And then we have return value and side effect, which are some optional things that I will talk about in a little bit. The example that I've got here, we've got a pizza store and we're checking an order, and we want to check the order without checking its voucher that's associated with it, because we want to make sure that we're limiting our tests to only checking the things that we really need at any given place. In this case, this thing that you can see called good voucher order, that's just a fixture that I defined elsewhere so that I can use it in a bunch of places. But when I call this, and it's calling this pizza store utils is voucher valid thing, what should that return? This mocking out of a function might still not work. So what we can do is pretend another piece of code is working without calling it for real using the return value function. And in this case, we have set in the middle of the code there things saying mock voucher checker return value equals true. So when we call that, it gets a true value back, and the rest of the check order function goes, oh, okay, no, voucher's fine, we can just keep on going with the rest of the stuff. And any other thing that breaks during that will not be voucher related. Or we can do this directly in the annotation. So in this case, I've said return value equals false right up the top there. And this one is checking that if I've got a bad voucher, which confusingly has the fixture name good voucher order here, it will actually say, no, this is a bad order because we've got a bad voucher, regardless of the fact that the good voucher order is good. So how do I check my code is calling the mock function in the right way? There are a bunch of different things for this in the unit test.mock docs. And you can assert things are called. You can assert they're called once. You can assert they're called with different things. There are a variety of different ways to do this depending on your needs. For this example, I have checked that my thing is called right using the assert called once with. And in this case, I am checking that my voucher checker has been checked with the voucher code from the voucher in my fixture. And there is a second option. You could do something like this where you inspect your mock object after you've used it. It is a bit more verbose, but it does give you the opportunity to explain your assertions, which you can't easily do inside of the assert called once with. In this case, we're using mock voucher checker call args.args, which gives us the arguments that you've called the function with. There is also a quargs for keyword arguments. Can I check whether my code is not calling a mocked function? Yep, there's a thing called assert not called. And in this case, I am wanting to check a fixture that doesn't have a voucher attached to my order. And I want to make sure that it's not checking the is voucher valid function at the top. And as to why I might want to check a function or mock a function that I'm not calling and check that it's not being called, yeah, that's to make sure it's not being called. And that's something that is especially important for things that might have side effects depending on where you're testing it, that you don't want it to be sending emails to people or indexing the wrong thing or various other things that might not be good to have outside of a clean testing environment. So can I check this several times in a row? We can give it a go. This piece of code, I am checking a good voucher, a no voucher, and a bad voucher. I want the first two to be true, and I want the third one to be false. Is this going to work? Is it all good? Not quite, because that third one there, checking on the bad voucher order, will be true because the return value there is always true. So how do we deal with having multiple things in a row and having different outcomes? That's where a thing called a side effect comes in. And here we've got a list of 3 outcomes, which are a true value, a false value, and raising an exception because something else broke, which are the usual kinds of outcomes of something where you're calling something far over there that might have something weird happen to it. So in this case, we have first checked the good order is good. Then on the second one, we check that the bad order is bad. And then on the third one, we're using a thing called assert raises to anticipate an order exception when we check an order with no order at all. And at the bottom of that, since we've checked it 3 times, we're also just checking the call count to make sure that everything adds up as expected there as well. If you run out of values on a side effect, you will run into a stop iteration exception. It's because you've run off the end of the iterator. If you want to reuse values that you had previously, you can use reset mock. And if you want to have just an arbitrary number of differing results, you can do interesting things with generator functions about that. There are, again, things on Stack Overflow for that. So next we are looking at how we define some of our test data with factories and fixtures. So in the context of testing, we've got fixtures, which are standard pieces of reference data, and factories that can create synthetic data for us from blueprints on demand. And whether you use one or the other is often a balancing act, depending on the complexity and maturity of your code. You probably want to avoid over-engineering things when your requirements are still evolving, so you don't want to build yourself a big complicated system to generate these structures for you, only to find out that you need to fix a bunch of things, change a bunch of fields, do everything all over again. But on the other hand, you probably want to build some more scaffolding around parts of your project that are more complex and more critical to make sure that they do work all the time, every time. So the best way to do this might depend a lot on your framework. Some frameworks and some factory systems and so forth work nicely with each other. Can I tie something into an existing object relational mapper from a framework? For REST endpoints, can I, for example, borrow from the Open API schema? Does it have examples that I can use and copy and just put some values in and call that a fixture? Sometimes yes. In this case here, we're looking at setting up a fixture and then using deep copy to change the fixture and alter a few values to break an otherwise good fixture so that we can test for certain errors. And using deep copy here means that we don't run the risk of changing mutable data in things that we've set up when we've set up our test cases, so that you can be a good neighbor and make sure that you're not breaking things for other tests as you finish the one that you're doing. So here's an example. In this case, I'm using Django and Factory Boy, and this is a voucher factory. And it's based on the Django model factory that comes bundled with Factory Boy. We have a meta thing there that's just telling us where the model that this is attached to is, so it knows what it's creating. And we've got a bunch of fields here. We've got first one there, which is just a sequence that I've defined to be VCH, some bunch of numbers, padded out to 5. And that's a char field. Then we have a couple of date fields with a fuzzy date generated in January for the issuing date and in December for the finishing date. And our last one there is using a Django choice field, which has a variety of choices, and it's just randomly choosing one of them. Okay, here, how does this look when we're using it? We can do a voucher factory.build, which will, in this case, create it in memory and in the code, but not actually save it to the database. Or we can use .create to build and save a voucher and override a few values as we go. It's also good for creating large amounts of data in bulk. So with that lower one that we've got there, we're using create batch, and we're building a batch of 10 vouchers, none of which have already been redeemed, so that we can potentially do a bulk check sometime later on. You can get fancier with sub-factories for sub-models, using traits and things like faker that allow you to make names and addresses. It's also localized in some places so that you can specifically get names or addresses that sound like New Zealand ones, for example. So there's a lot of versatility in that. Okay, with that sorted, let's go back to making a mockery. So mocking is easy when you've got only one thing to patch for certain values of easy. It's more fun when you have several moving parts, and it's much more fun when your code has a lot of moving parts and you want to be selective about what gets returned and when. So how do we go about looking at these things? Can I use several mocks at once? Yes, you can string several of those annotations we saw earlier together, and you get something like this. One of the weird things about this is that it's in the order from the outside in. So we end up with mocking out 9 and mocking out 6, but in the function annotations, the function parameters there, it's mock 6 and then mock 9, so it's the other way around. And in this case, we have a function that is calculating the answer to life, the universe, and everything. No pressure. And we want to make sure that that 6 part of it is called and that 9 part of it is called, and in the end we get 42, which is the answer to life, the universe, and everything if you have studied your Douglas Adams, which I have. So you can do it that way, or you can use context managers. That allows you to set them up inside of your function without having to put them into your test function parameters and all of that. And you get a much more natural order, so we get our 9 and 6. And it's in there as 9 and 6. And then we do the same thing, get the same result, all good. But if you have a lot of things to mock all at once, then you can get all sorts of very bad off to the side indent errors by doing it this way. Luckily, in more modern versions of Python, we can chain these context managers together, and we can bring in other kinds of context managers as well if we need to. So in this case, we have the two mocks as before, and they are inside these brackets, which allows the width to chain a bunch of context managers together. So we're mocking out 9 and we're mocking out 6, and we are also checking for warnings so that when we calculate this answer to the meaning of life, the universe, and everything, and use deep thought, and it gives us a warning that you're not going to like it, then we anticipate that that warning is going to happen and we can test for it. So there are a few different options that are available to you there, and deciding which of them is going to be clearest is a balancing act. There's also just thinking about maybe easy to set up all your mocks at the front of your tests, but sometimes you will want to have them close to the action so that they're there for contextual purposes and it's a little bit easier for understandability. If you have lots and lots and lots of contexts, there's things in context lib for this. So this exit stack thing is essentially a context manager that just allows you to push in a context and push in a context whenever you want to. So if you had to, for some awful reason, open 10 files at once and read from all of them and knit them together in some fashion, then that would allow you to do all of the opening there, and then when you come out of the exit stack, it will just exit each of the things for you. Okay, so can I set up a standard set of mocks so that we don't have to define them every time? This front loads some complexity into your tests, but it can make things a lot easier later if you have a standard test, a standard bunch of them that you want to potentially mock out all of the time, and maybe override and change here and there. So the first page of this bulk validation test case, which bulk validates a whole bunch of orders, mostly looks like this, this parameter definition. So here we have 4 service calls that I want to mock by default. I'm setting up opportunities here for adding return values or adding side effects to each one of them. Making sure to document your expectations here, because there's a high chance of confusion in something like this if someone sees one of these things for the first time and doesn't know what the hell you're doing. So there is a piece there that is labeled document your data expectations for the test case here. Okay, so once we've done that, we supply some known good fixtures or factories for each one of those things. So at the top of this, I have a mock delivery location request, and this one is mocking whatever is in patch delivery location. I have these things up at the front of my test case just to make it easy to know what things I'm likely to be mocking in any given place, so that it's easier to maintain later. And in this piece of code, I am taking stuff from my fixtures, fixture delivery location defaults, and I'm dumping out a bit of JSON from that because this is an API test. Or if I have the side effect set up, then it will give me a side effect or a list of side effects or a generator or whatever else I need. Second one, much like the first, only in this case we are building a batch of things from a store supply response factory as opposed to from a single fixed fixture. So yeah, those patch constants are essentially making it easier for the border controls on your code, so to speak. So you know what this thing is likely to be pretending to talk to. Hey, so what does that self_patch thing that was in the last function do? That's a bit of magic. I stole this from Will Hughes, a former colleague of mine. But yes, essentially what this thing is doing is it's building a keyword arguments directory with some overrides if you need them, building and starting that patcher, and instructing the test case to stop the patcher once it finishes using this add cleanup at the bottom of it. So that's some good magic that helps our function to be a good neighbor and means that it's cleaning up after itself as it goes, so that we can worry less about it interacting with other things. How does this look in practice? This is a happy path test that builds us a CSV file from a fixture using a build CSV helper, and then builds ourselves a validator class. And once we've got all of that kind of stuff sorted out, and that bulk order should read payload, and I'll fix that later, we're essentially just checking first that the validator has received as many rows as we expect it to. Then we start our patches, then we run our checks, and then we verify the outcomes. So we're making sure that the validator is running all its checks, and that we have valid outcomes, so no other errors. And then we check that we have called the delivery locations request and done it with the appropriate things in our keyword arguments. And in this case, we are making sure that it has done a bulk check for 10 different addresses. So far, so good. Here is a bad version of that, the unhappy path. In this case, we are taking our existing fixture and messing with it. Wilmington, Delaware is too far away to deliver a pizza without some kind of portal technology, so that's not a place that we can send pizza to right now. You start our patcher as before. In this case, we are overriding the return value with our new payload. Run it as before, we check that it's run, we check that it's failed, and we assert that a certain error has shown up on a particular row. Next up, how are we off for time? So, the source of fragility in testing is relying on time-bound data that can become obsolete for real-time inputs. The quote here is paraphrasing from an actual project. No people named, it wasn't us though. I updated the year in the fixture, and so it works again now. There was a particular thing that was failing on a yearly basis until someone just changed the value. But no one had had time to go and fix it. Another source of that is cargo colting similar tests with similar functions. So we copy paste, we change the parameter and move on. And then someone else comes back to it later and it's still got doc strings from the previous test that you copied it from, and no one understands why it is the way it is. So, thinking about these, can we make some of our tests timelier and more intentional? Can I handle time-sensitive data? Most things, when you write a test, you'll probably write it with dates and times and that kind of stuff around about the time that you're writing the test, which is, I guess, interesting for archaeologists, but not actually useful necessarily for making sure that the code is robust. So can we find out if they'll still work in a year's time as expected, or 10 years' time? So what I use for this is a thing called freeze gun, and that changes when now is according to your system. So your date time now will be what this thing says instead. In this case, we have a test where we are locking the time to the 5th of November, 1955, when apparently a lightning storm is going to strike the clock tower, which will allow someone to time travel back to the future. Just as an illustration of concepts. This is especially useful for when you have data recorded from, for example, an encrypted payload. So you have done a test against something's test environment, you've got some values back, you've saved those values, Next time you try to run the test, it won't work because when you try to decrypt it, you find out that your keys have expired. Well, poop. So you can lock it to a specific time and have those time-bound data fixtures and so forth still keep working as expected. But if the processes around them change so that they stop working, you can find out. Can I handle a lot of similar cases elegantly? This is where we use test case subtest. And there are other things for other frameworks. PyTest, for example, has parameterized for this, but they're sort of much of a muchness as to how it goes. In this case, we have something which is looping through a bunch of our test values and making sure that our check values match up with the appropriate results. You might want to consider adding something descriptive to your subtests if you have a lot of them, because it will make it easier to work out which one in particular is the one that you care about and what it's supposed to be tested for. So an example of this, we have set up some standard data here and we have defined our test cases. Our standard data, we have an issuing date, we have an expiry date, we're creating a voucher that's not redeemed, that has those dates associated with it. We've got some acceptance criteria at the top, so a voucher should only be active between the issuing and expiry dates. And we have some cases that we've got here as to when it will be active and when it will be inactive. Moving on down the code, this is how we would use these things. So in this case, I am taking those cases that I've defined and unpacking the tuples so that they're out into their date, active, and message variables. And I've got a debug there that I should have got rid of, but never mind. It's sometimes useful just to make sure that we're doing things in a sane way. So in this case, we have two context managers. We're using self.subtest, and we're throwing those values that we had in as keyword arguments on that. We are freezing time to the date that is specified there, and we are then checking that on the specified date, the voucher has the level of activity that we're expecting. So it's returning a true if we're expecting a true, it's returning a false if we're expecting a false, and gives a small explanatory message down the bottom of the assert equal. So what will we get when we run these subtests? We'll get an error because I've done one of them wrong. So what does our subtest failure look like? In this case, we have this thing saying, something has broken in test voucher active times in this place. We've got here, the description and the date on which we were testing and what we were expecting this to be. And this is the top of our doc string here. And we've also got this, as before, assert error, false is not equal to true, which isn't very useful by itself, but we've also got a message down the bottom of that saying, tested on this date, should be inactive on expiry day. So we're explaining the problem, we are showing the case and parameters, we can assess whether the outcome matches the intent, then we can find the broken test and fix it. Now in this case, we have a thing there saying should be inactive on expiry day, but we also have a thing at the top saying active equals true. And as it turns out, our problem is in fact that we have written this test wrong, that true there should be a false, and we can just fix that test and move on because we have the intent already written next to it as to what it should be doing, so we have a good idea. So I'm probably getting close to out of time at this point, but here are some other edge cases and ideas. We might want to do conditional tests. Unit test by itself has skip if and skip unless, and you can pull that in from environment variables if you're calling it or if you're using it in the CI pipeline or that kind of thing. But other frameworks have tags and can do sort of matching on specific things better than other things can. For file processing, if we're wanting to test, say, uploading a file to an API, you can do weird things like turning your big string of data into an in-memory file-like object and then treating it like a file in the rest of your code. You might want to consider the Python Magic library to work out what kind of file type you have, because things that come in from the content type fields and requests are often lies. One thing that you might want to do if you've got big complicated transactions that have multiple parts, like various flows for single sign-on or for processing payments or various things like that, you might want to record a bunch of requests and responses. Can be handy for just replaying those, running something and testing that all of your cassettes have played in something like VCR-Pi. But on the other hand, there's some fragility there, and there's potentially also security. So if you are recording your tests in a test environment, you want to make sure that there aren't any credentials or other interesting information being stored in the headers alongside your payloads. If you're testing something that has to work across multiple environments or multiple Python versions, Tox is good for that. You can set up so that you can, for example, test on Python 3.9, 3.10, 3.11, 3.12. Can be a bit fiddly to try and get all of the different Python versions installed at once, so PyEnv is a useful tool for that, even if I did have to symlink across a bunch of different versions to get everything into the same place. Or indeed, you can just set up CI infrastructure for that on your favored platform. So I think that's about it for me. Any questions?
Thank you, David. A most informative talk. I've learned some things to go and look up later. We have about 5 minutes for questions. If anyone has anything they would like to ask, please.
Thanks for the talk. I'm curious about this cassettes VCR transactions. How do you use that? What does it actually record, and how do you test those complex flows?
Okay, yeah. With that, there is a context manager for that, for using cassettes. And you use cassette and you specify a name for your cassette. These things can be set up with recording modes. So when you're first doing your requests, you might do it with a new episodes recording mode for that, and it'll record all of the new requests that come in. Once you've got everything the way that you want it, you're probably going to change it to a recording mode so it's not picking up anything new. And then you can test it once you've finished and just make sure that your context manager says that all of your requests have played, and that'll let you know that it's gone through the full range of those things. For something that's irreducible and it's a big complex mess of things, you might have a whole bunch of requests in a row. But if you want to sort of split it out and check it in certain places and that kind of stuff, you might end up having several cassettes used in different context managers throughout a big test. So there are a few ways of doing that kind of thing, and a bit of versatility about how you integrate it.